Good afternoon. Am I audible? I said good afternoon. Am I audible or not? Yes, very good. How are you? Everyone fine? Tell me. Yes. Good. Good. Okay. Now, good. Now, come to the point. What is the point? Yesterday, I have given to all of you basic information. Basic information, or you can say just tried to improve the interest regarding these topics, whatever we are going to discuss. And it is very interesting. History is there. Now, these days, we know electron mass, in which manner it is going to ionize the substance and everything. At that time, think, when no instruments, nothing is there, very less equipments, and in that time period, people are doing that much hard work. And so that right now, these days, we are using all these instruments and all, everything. It depends on all, whatever discoveries happen at that days, in those days. Okay, good afternoon. Now, so what we will do today? Today, very important work. We will little revise all these things, and also we will write in a proper manner. Yesterday, I just given the brief information. That was the first lecture. So I just want to tried to create the interest, and now I hope. Okay, hi, hello, chalo, new. Now, very good. So now let's start. We will start discussion and we will write all these points today also, and then we will move further. Ki after neutron, what happened and who has given the name electron, all these things discussion we will do. And also we will start the discovery of proton. That is also very interesting. And they are connected with each other. Logical, everything is logical. So now come to the point. So first we will revise also and we will write also. So now ready, everyone? Let's go. Now, first point, we know कि atom has atom. Dalton said not divisible, but further studies said it is divisible. And if it is divisible, so atom has subatomic particles. Subatomic particles. Those subatomic particles, so many subatomic particles was there, but main fundamental subatomic particle is first electron. We are representing the electron like that. Second fundamental particle, proton. Third fundamental particle, neutron. Other than means other than them, we have different subatomic particles also, like positron, maybe you have heard or not, mesons, neutrino, antineutrino, but their role is very limited to build the atom. But major role to build the atom is actually electron, proton, and neutron. After that, we have started the discovery of electron. Discovery of electron. Discovery of electron has started by one experiment. The name of the experiment was cathode ray experiment. Cathode ray experiment. This experiment, now it is a mixed study. Not only one scientist has role here. So many scientists are there. Different kind of scientists came and they have given their contributions. And in the last, whatever conclusion came, on the basis of that, it has said कि in whatever cathode rays are formed, they are formed by the negatively charged particle, and that negatively charged particle is what? Electron. Very good. So cathode ray experiment, whatever the cathode ray experiment was there, in that first one setup was there. Very good. So setup of this experiment actually this credit goes to whatever setup was there. Yesterday we have seen one setup. That credit, yes, that credit goes to William Crookes. For setup, credit given to the William Crookes. First time he has arranged that setup. Okay. So now William Crookes, very good. William Crookes. He has arranged that setup. What was that setup? We will draw. Very good. Again, in proper manner we will draw here. In that setup, we have one glass tube. We have one cylindrical glass tube. One cylindrical glass tube. Something like that. First thing. After that, whatever gases was present inside that glass tube, they tried to remove with the help of vacuum pump. So one vacuum pump, just think it is a vacuum pump setup. Vacuum pump. Very good. After that, with the help of this vacuum pump, when all the gases are extracted out, so obviously any common sense, use the common sense. In the glass tube, when cold drink is filled, when inside the cold drink bottle, if you will see, CO2 gas is filled, yes or no? And inside, and because of that CO2 gas, pressure is created. Means whatever pressure are present inside that glass tube, that is only because of gas. If you will try to remove that gas with the help of vacuum pump, what will happen? What will happen? Pressure will decrease, and we will try to reach, or we can say the pressure will reach near to zero. Or less than zero, very zero. Very zero, not a word. Less than zero, so much less. Around 10 to the power minus 2 or 10 to the power minus 3 to 10 to the power minus 4 atm. Very, very less pressure. And very, very less pressure means near to vacuum. No any single gaseous particle is inside that. Negligible. Okay. After that, he has arranged two electrodes, one anode, very thin metal plate he has taken, and one cathode as an electrode, and these electrodes was attached with the battery, very heavy battery, not as normal battery. Whatever batteries we are purchasing from the market, very small battery, 2.2 volt, 2.1 volt, like that. 10,000 volt. So much huge voltage, 10,000 volt or more than that. Here voltage near to 10,000 voltage, and applied one switch connected with the electrode. So you can say this was the setup, basic setup, which actually given by William Crookes. Okay. And now we know that we have applied ZNS screen. So just assume ki here inside the glass tube, zinc sulfide coating is there. Zinc sulfide coating is available. Very good. And zinc sulfide coating has one rule. Any charged particle will come and hit with that, it will start to give spark or no, spark is not good. It will start to give what? Shining. And shining means inside that any charged particle is available. That is the sense come in the mind. Now, this is our ZNS screen. Okay. Because positive plate attached with this, so we will say it is anode. Because negative plate is attached with this electrode, we will say it cathode. So this was the basic setup which given by William Crookes. Okay. Okay. Very good. If you will observe this setup, so there is a very famous question which has already asked in the NEET in PYQs. What was that? Ki in this setup, cathode ray experiment, what was the pressure and what was the voltage? So what will you say the answer? High voltage and very low pressure. So inside the cathode ray tube, what was the means in the cathode ray question was like that ki cathode ray experiment when has performed, what was the condition? High pressure, low voltage, low pressure, high voltage, low pressure. So third one, what we will mark? High voltage, low pressure. In this condition, actually, cathode ray was generated. So this was the setup, which is given by the William Crookes. After that, yesterday I have discussed so many points. So one by one, all those points we are writing also, and we will analyze also. So now, after this setup, after the formation of this setup, William Crookes has performed the experiment also, but William Crookes was unable to identify what was happened. But he said something in the sense that one rays definitely formed, but how? What was the reason? It is formed by which material or which mass particles? He has no idea. Then what happened? After William Crookes, other scientists came, like in that famous name is what? Plucker and Hittorf. Now, ab dekho. Point is like that. Whatever cathode rays was discovered, so properties of the cathode rays was majorly discussed by Plucker and Hittorf, but not only they are. So many other scientists are also there. Then all the information collected. So majorly whatever credit gone, all these points are the just general knowledge. They will never ask also. But major credit given for the study of the credits of which rays? Cathode rays to them. Who are those people? In them first is what? Plucker. And Hittorf. These two people was the first time, or you can say majorly discussed, or major studies they have done regarding, you can say what? Cathode ray. Now here, in this voltage, high voltage, low pressure, one rays is going to form that was coming from cathode and moving towards anode side, which was actually known as cathode ray. These are what? Cathode rays. Very good. Cathode rays. So basically this was the setup, and in this manner cathode ray came in the picture. After that, properties. First property, cathode rays follow straight path. Correct or wrong? Very good. Straight path. Very nice. Who told they follow the straight path? What was the point by that they was concluded? The conclusion came ki it is moving in a straight path. Just they pass the cathode ray on a wooden block and they observed shadow form. Very good. What has formed? Shadow form. And shadow formation, whatever happened, on the basis of that, this is shadow, this is shadow, and because of the formation of this shadow, obviously, now I have given direction from this side, so that side shadow will come. Now check the direction of the cathode ray. Now think cathode ray is coming like that, so it will hit this wooden block, and behind that shadow came. It means they follow straight path. Very good. Very good. After that, point number 2, second property. Cathode rays have ability to show heating effect. Very good. Heating effect. In which manner they have obtained this property? Again, cathode rays they have taken, and they have kept here light metal block. They have kept here light metal block. Light metal block. And when with that light metal block, these cathode rays are going to strike. Cathode rays are going to strike. So obviously, in this collision, heat formation happened. What happened? Heat generation. So heat generated. Heat generated. Or you can say this block temperature start to raise. That also you can say. So heat generation happened. Or metal block temperature raised. So from here, another conclusion came कि cathode rays has one more property कि they can create what? Heating effect. They can show what? Heating effect. Now, after that, next property, third. These rays has ability to penetrate thin metal foil. Thin metal foil. If very thin foil you have kept. Thin foil. So what will happen? If you will pass the cathode ray, so it will not like that they will blocked. They will hit, penetrate and move that side, opposite side. So thin foil if has, so they maintain, you can say they have that much energy कि thin foil cannot stop them. They penetrate and move out. So penetration power they have also. They have penetration power also. So thin foil, they can penetrate and move out. That much energy they consume. That is the point. Very good. After that, next property, fourth, cathode rays can rotate light wheel. This is very, very, very important experiment. This was when cathode rays came, hit to the light wheel, and light wheel start to rotate. Means energy, cathode rays transferred their energy into what? Obviously, light wheel will start to rotate. Means what happened? It has obtained the energy, and who has given that energy? Cathode rays. And cathode rays are what? Moving. So velocity they have. And velocity they have, and if they are transferring the energy, means they have kinetic energy, and if they have kinetic energy, means half mv square formula we can use for cathode ray. And any person, any object, any substance, if we are able to use half mv square, it means mass particles are present, or you can say it has mass also. That is a very important discovery with the help of this experiment. So what happened? This time a very light wheel taken, very light wheel, and when cathode rays went and going to strike them, what happened? This wheel start to rotate. This wheel start to rotate, so it has said cathode rays transferred energy to the wheel, and which energy they have? Half mv square. Means kinetic energy. They have velocity, they have mass, and if they have mass, it has cleared right now कि cathode rays are formed with the help of mass particles. So now till this it was clear that there is a cathode ray. Yes, it exists. Yes, it formed from cathode. Yes, it is coming from cathode. Yes, and by which material it is formed? They have mass particles. It is formed with the help of mass particles. Very good. It is very important. Mass particle. Good. After that, fifth property. Fifth property, when people has applied, or you can say Röntgen, whatever study has done, Röntgen has done what? When cathode ray is going to strike, with heavy metal, like tungsten, W, it is represented as W, tungsten. Then what has observed? One new unknown rays was formed, because at that time no one knows that name. They have said formed, which was known as X-rays, and after that no one given the name to this person. So till right now it is what? X-ray. Very good. So what happened this time? Very heavy metal take, very heavy metal, just like this. It is a very heavy metal, tungsten. Cathode ray is going to strike. This time when cathode ray going to strike, they strike because metal is very heavy. So one new different rays formed, which was actually coming from tungsten. Light metal you will take, only heating effect happen, nothing else. But heavy metal generate this also. In case of light metal, only striking happen. After that, you can say heating effect happen. But for if you want to easily find X-ray, you have to take what? Heavy metal here. Okay. And this unknown rays are known as X-ray. Very good. Next property was what? Was like, which one was it? Fifth. Now come to the sixth property. Sixth property is like, if any electric field or magnetic field is applied, then they are going to deviate from their original path. Deviate from their original path. And due to this deviation, one very important conclusion came that those particles by which cathode rays is formed, actually they have negative charge, because that path of deviation move and they attracted towards positive plate side. So now just one diagrammatic representation we are going to do. This assume it is electric field applied, external electric field. This side I am going to take positive charge or positive plate, and this side I am going to take negative plate. And now from this side cathode rays are coming like that, and once they reach, just when they try to enter inside the electric field, they start to deviate and move and attracted towards positive plate side. If they attracted towards positive plate side, it means they have negatively charged particles. Very good. So from here one conclusion came, because cathode rays attracted towards positive plate side, so that we can say the particle by which cathode rays are formed have negative charge. They have which charge? Negative charge. Very, 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 very important conclusion. Okay, what happened? This is cathode ray. This is cathode ray trying to enter inside the electric field. Because it is attracted negatively charged plate side, it is attracted towards positively plate side, it means they have negative charge. That's it. Very good. After that, other effects, other properties which I have not discussed yesterday. Now the new one, seventh. Very important. It has also observed if you will take photographic plate. Do you know photographic plate? Photographic plate is what? Photographic plate, negative one plate, photographic plate. Anyone has idea? Anyone? Right now we are going to click picture with the phone and all. Earlier camera and it has reels, and there one reel has black color reel. With the help of that, photos was actually captured earlier. So if photographic plate, it is photographic plate, and now cathode rays are going to strike with them or with it, you can say. So what will happen? It will change its chemical composition. Means what you can say, cathode ray has ability to change the chemical composition of photographic plate, like sunlight. With that camera, when you are going to click the picture, for some time shutter, for very few seconds, shutter is going to on, light is coming and chemical composition change happen, and we are getting the picture with the help of that photographic plate. Similarly, when cathode rays are going to strike to that photographic plate, there also chemical composition change observed. Okay, this was the seventh property. Eighth, very important also, because eighth is helpful in different place, I will tell you. So first try to understand eighth property also. What is the eighth property? Eighth property, very important also. Concentrate here. Very important. Again, I am saying it is very important. Concentrate here. Cathode rays has ability to ionize the gas. Very, 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 very important. Very important. What? Cathode rays has ability to ionize the gas. What is its use and in which manner? What is its sense also? Listen, see this side. Very important. Come to the point. What happened? If cathode rays are going to strike, assume it is cathode ray. Cathode ray is going, and here H2 molecule is available. Hydrogen. Think hydrogen gas is there. H single bond H. This is hydrogen molecule. With this hydrogen bond, you can say hydrogen molecule, when cathode rays is going to strike, first it will convert into in its atom. Here H atom first, and here another H atom, and this H atom will release electron. Ionization. Ionization means what? Electron will remove out from this gaseous atom. It will convert into H plus electron, and it will also convert into H plus electron. Very, 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 very important. These are the cathode rays. These cathode rays are going to strike with the H2 gas. With that H2 gas molecule, when cathode ray is going to strike, first it will go into in its atom, and these atoms then ionize and convert into H plus ion. Means cathode rays can ionize the gas particles also, or gaseous molecules also, or gaseous atom, you can say. Like one more example. This is the first example. If I am going to change the gaseous particle, like helium gas, if I have taken. Which gas? Helium gas. If I am going to take helium gas, this is helium gas atom. Cathode rays are coming and going to strike with the helium gas. Helium gas atom will also ionize, convert into He plus 2 electron came out. Means what? Very important. Why I am saying very important? Because it helps to find proton. In which manner? I will tell you. Very good. So now, what happened? Cathode rays are those type of rays when they are going to strike to the gaseous particles. Those gaseous particles are going to ionize. That is also very important. Very good. So these 2 points. Other gases also you can take, those will also go and ionize. So now, so much study we have done, so many properties of the cathode rays has studied right now. Scientists has studied about all these properties, and then finally they reach on the final conclusion, and that final conclusion actually first given by the Sir J.J. Thomson. Sir J.J. Thomson. And different scientists has studied all these properties. Now J.J. Thomson was doing also study, and he has given one conclusion. What is that conclusion? Key cathode rays. Now who is coming in the picture? J.J. Thomson. Sir J.J. Thomson came and said, first point, cathode rays are formed by negatively charged particle, and he has given name. He has given name. What? Negatron. So now first time those particles, whatever are going to form cathode ray, now one person came, Thomson, and he has given one name, Negatron. After a few years, another scientist came and he has given what? He has given new name, that is electron. Who was that? Stoney. Stoney has given name electron. And actually electron name is more famous than negatron, so that we all are saying what? Electron. So electron actually name given by Stoney, but about that already Thomson has said कि those negative particles are what? Negatron. Okay, very good. So if we try to represent the cathode ray, in which manner we will represent? So I am trying to represent the cathode ray. Assume this is one cathode ray. This is one cathode ray, and inside that so many number of negatively charged particles present, and which are actually what? Electrons. So this is cathode ray, and so many, I'm not saying that much, so many number of electrons means so many negatively charged particles, just they are going to arrange in a linear line and they are going to move in one side. That whatever ray will generate, that ray is known as what? Cathode ray. So in this manner, discovery of electron happened. But after the discovery of electron, a very big question came, and very challenging also. What is the mass of electron? And if we are saying it has charge, so what is the charge of electron? These two questions, very dangerous. First, by so many difficulties, after so much difficulties, they obtain one conclusion कि there is a charged particle, and that is negatively charged particle. A problem is what? Next question arises, what is the mass of that charged particle and what is its charge? Up now, Thomson was studied so much more also, and he has given the mass of electron also. So next point, second point, mass of electron is given by Thomson, and how much he has calculated? Near to ME means mass of electron. Mass of electron is calculated near to 9.1 into 10 to the power minus 31 kg. Everyone has to learn this mass value because in so many numericals we will use it. So near to that mass is calculated, and then another scientist came whose name was Mulliken. What was his name? Mulliken has done one experiment. What was the name of experiment? Oil drop experiment. In the NCERT, this experiment given. When you will come in the class, we will discuss this experiment in detail. Very fine question are possible to come with this experiment. Oil drop experiment. Who has done that experiment? That is the first question, and it has already asked. The oil drop experiment is done by, so what will you say? Mulliken. What will you say? Mulliken. And with the help of oil drop experiment, what was measured? So you will say charge of electron. And how much? So now I am writing charge of electron, I am representing as a E. E means charge of electron. Charge of electron equal to minus 1.6 into 10 to the power minus 19 coulomb. So in this manner, we reached key inside the atom there is a one first subatomic particle we have obtained, and basic information we have find also right now. Key inside the atom, whatever subatomic particles are there, in them one is what? Electron. It has mass. Its mass came, as well as it has some charge. That charge value also calculated. Okay, very good. After that, there is a term specific charge. So many times question has asked on this term. That term is very important. What is the name of the term? Specific charge. What is the name of the term? Specific charge. Specific charge. Or another name is charge by mass ratio. Charge by mass ratio. Charge by mass ratio. Now, there is a question which is sometimes asked. Ki, what is charge by mass ratio? Mass ratio of charge by mass ratio of cathode ray. Of cathode ray. So charge by mass, specific charge is a very simple thing. Formula already written. Charge of electron divided by mass of electron. If you will do, you will get specific charge. So now I am going to give you homework. This will be like 1.6 into 10 to the power minus 19 divided by 9.1 into 10 to the power minus 31 coulomb per kg. You will solve it. You will write here. Whatever will come, that is actually known as specific charge or charge by mass ratio of electron. This is simple thing. Maybe they can ask this ratio value is what? Simple question. You will solve it, you will get the answer. Not tough. Mathematics, that much we know how to divide all these things. But another important question, and very important. Do you know what? They sometimes ask, if we will fill any gas inside the tube, that experiment, remember that setup? Do you have remembered? Do you have idea about this? This setup, where it went, where, yes, this. Here, vacuum is created actually right now. What will happen if you will not create vacuum? Fill the gas. And if you will fill the gas, still in the high voltage, and pressure has no sense right now because gas is filled, so some pressure will come automatically. Okay. So still cathode ray can generate. If generates, so its behavior, or you can say its nature, will change or not. That is a question. What is the question? Again, listen, it is a very fine question and very nice question. What? If we will fill gas inside that tube, we will not create vacuum. And then we will apply that much high voltage. At that time, is that cathode ray will generate? And if it will generate, so its nature will remain same or nature will change? That is a question. We will discuss about this question answer when we will discuss, or we will finish the anode ray experiment. Anode ray experiment is what? Anode ray experiment is the experiment by which proton is actually came in the picture. And what is proton? How it came in the picture, and why proton people are going to search. There is a question mark. Who has told and from where this idea came कि proton also possible inside the atom. We know right now, electron, proton, neutron. Electron was discovered, and after discovery of electron, who told कि proton also there search? So the logic is there, a very simple logic, very simple. You can think, you can find also. What is that logic? What is that logic? Listen. Atom is a neutral body. Yes or no? Give me the answer. Atom is a neutral body. Give me the answer quick. Yes. And right now we find inside that one negatively charged particle. And if negatively charged particle we obtain, then it is a common sense to neutralize that negative. Plus is also present. Am I right? If only electron will be there, so atom should be negatively charged, na? But no, atom is not negatively charged. Atom is neutral. And if atom is neutral, it means positive particles are also there. Very good. And if positive particles are also there, now every scientist start to run, he search that positive particle. Why? What is that positive particle? Because net atom is neutral. And if it is neutral, electron right now everyone has obtained, means positive particle is also there. And now from here the concept of searching of positive particle has came in the picture, and everyone start to find what? That positive particle. Again experiment starts. So many scientists came, they are doing experiment in their labs, daily experiments to experiments are going on, and then one person got success. Success everyone has find maybe, but he has identified. Because sometimes what happens, same experiment done by other person also, but he is not able to analyze that much better whatever another scientist has analyzed, and the name of that scientist is what? Goldstein, not Epstein. Don't think Epstein is the ancestor of Goldstein. No. Epstein is a different person, and Goldstein is different person. Okay, so now we all are going to start the discovery of proton, that positively charged particle. So for discovery of proton, one scientist was there. The name of that scientist is Goldstein, and Goldstein has done anode ray experiment. So now new heading, anode ray experiment. Experiment. Who has done that? Goldstein. Goldstein. Not the ancestor of Epstein. Is it okay? Very good. So Goldstein has done a very small change. Very small change. Setup is same setup. Two change he has done. Two simple change. First change, he has taken cathode right now, not a solid. Taken perforated. Perforated means porous. Porous means think this is cathode, and I will take a small needle and create so many small pores inside this. Pore, small pore. Now, so it is a porous cathode, or you can say perforated cathode. First change, he has done this. So now we are trying to draw first the setup of anode ray experiment. Again glass tube taken, very good. Cylindrical glass tube. Now again he has taken one anode, and it is very interesting. It is anode because it is connected with the positive plate of the battery. Positive plate of the battery. Switch. And here he has taken a perforated cathode. How to draw here? So I am just drawing. I have explained you what is the perforated cathode. Not continuous. Small pores are there. So this is right now you can say perforated cathode. And as usual, this side one screen, ZNS screen applied. Similarly, this side also one ZNS screen applied. And this time here not vacuum, 100% vacuum not there. Few amount of gases are filled this time. Pressure is also little low, but not so much low. Few amount of gas is filled inside that. And which gas? Think about H2 gas. H2 gas is filled inside that. I have taken only 3 molecules, it is enough. So many was there, but just for representation, 3 I am writing. Okay, this is the setup. Again, very high voltage, more than 10,000 or more than that, 10,000 or more than that voltage has created. Pressure not so much high, but not so much low also, because few amount of gases are filled. So pressure automatically you can say ki in compared to previous setup, little pressure will be high. It is a common sense. Now think, switch on. What will happen? Very high pressure. High voltage. This time, what will happen? Think. Again, as usual, cathode ray formed, because this much high pressure, high voltage, this much high voltage again generate cathode ray, means which side brightness will come, tell me? Behind the anode or behind the cathode? When cathode ray will form? Everyone tell me. Give me the answer in the chat box. Quick. In the comment box. Quick, give me the answer. Where? Very good. Behind the anode, what will generate? Shining. Brightness will come. So first, think it is the brightness. I am writing first. Shining came behind the anode, and we all know behind the anode whatever shining came means who is going to generate right now? Cathode ray, because in this much high voltage, that is the only ray which is generated. Am I right? Give me response. Quick, give me response. Very good. Now, do you know one very good thing happened? Last time when gas was not filled, only behind the anode we was getting the brightness, but this time right now behind the cathode also after some time, means first brightness came behind the anode, and we all know due to cathode ray, but this side brightness came or shining came, then after a few seconds one more brightness came. And this time, brightness came behind the cathode after shining, or after brightness behind the anode, after brightness behind the anode. Now one more time, or you can say now brightness came behind the cathode. And behind the cathode, if brightness came, do you know? It means one more rays generated, which is moving from anode to cathode side. Can I say like that or not? Common sense hai? Yes or no? This is the common sense. When we was saying कि brightness is coming behind the anode, means rays came from cathode and going towards anode side. But after this brightness, this time after a few seconds, one more brightness came in the opposite side. And opposite side came means again what happened? Again you can say this time what happened? Ki one more rays generated, and this is right now actually brightness came behind the cathode, means one rays is also in the picture, means one more rays inside the tube, which is moving, obviously, which is moving from where to where? Anode to cathode. Because it has observed it is moving from anode to cathode side, the name was given anode ray. But I am right now going to give you one question, and from here we will discuss in next class. The question is that, as we know, the cathode ray was originated from cathode. Yes? Correct? Good. Another question. Anode ray, is that generated from anode? Similarly, can we say like that? No. It feels like coming towards anode to cathode side, so that we said what? We said anode ray, but anode ray not generated from anode. About this question we will discuss in next class. I hope you have understand all these things. Just think about that. Yes, anode ray also known as canal ray, because it is perforated na, so obviously from that pores came, so that we are saying ki canal ray. But canal ray or anode ray is generated from anode? No. Cathode ray is generated from cathode? Yes. But why we are not saying ki anode ray originated from anode? Its answer will come in the next class. Bye bye.